Modern industrial food production relies on an endless, aggressive loop of intensive external inputs: synthetic chemical fertilizers, heavy diesel machinery, automated tracking systems, and strict everyday maintenance. We have been conditioned to believe that generating high-quality animal protein requires vast swaths of cleared land, intensive commercial infrastructure, and a relentless, costly input of resources. Yet, buried deep within ancient agricultural texts like the 2,400-year-old Yang Yu Jing, authored by a Chinese scholar and farmer named Fan Li, lies a profound biological anomaly. The ancient text details a small, highly localized water system that can outproduce traditional terrestrial livestock on the exact same surface footprint, utilizing nothing more than sunlight, baseline water, and the natural passage of time. For decades, modern agricultural archaeologists and historians dismissed these ancient inscriptions as poetic hyperbole or idealized regional mythology. However, extensive field data recovered from ancient rural villages across Asia uncovered thousands of localized household ponds that had continuously produced massive yields of food for hundreds of years without ever collapsing, degrading, or requiring a single ounce of artificial chemical input. Passed down directly from one generation to the next, these pools functioned as permanent, self-replenishing protein engines that sustained entire families. This reality forces an uncomfortable question against our modern methodology. Why does a high-tech, multi-billion-dollar industrial agricultural layout break down almost immediately without constant chemical intervention, while these simple ancient pools remained perfectly fertile, balanced, and productive for centuries? The friction deepens significantly when these systems are verified within rigorous, modern research settings. In controlled agricultural studies conducted in the mid-20th century, miniature closed-loop water matrices measuring less than 1,000 square feet, roughly the footprint of a small backyard swimming pool, consistently generated up to 350 pounds of clean fish protein annually. To harvest the exact same output from cattle, a modern farmer requires a massively larger land footprint alongside continuous grain inputs, intensive veterinary oversight, systemic physical barriers, and constant manual labor. Yet, in these specific micropools, no human brings external feed to the inhabitants, and no mechanical filtration cleans the system. The empirical data presents a massive, unresolved contradiction to modern production beliefs. How can a biological system with zero operational upkeep continuously generate more high-density nutrition than our most advanced, labor-intensive livestock operations? To resolve the glaring contradiction of the zero-input harvest, we must completely abandon the modern industrial concept of linear farming altogether. These ancient backyard structures do not succeed by raising a single isolated crop in a vacuum. Instead, they operate as a highly sophisticated, self-sustaining, closed-loop ecosystem. By deliberately interlocking distinct biological layers, combining specific avian behaviors, explosive plant growth, and a stratified, multi-species polyculture of fish, the architecture of the system transforms natural waste directly into a perpetual cycle of fuel. This interlocking mechanism optimizes the environment so thoroughly that external inputs are rendered completely obsolete. The entire self-feeding engine is driven by a highly active surface catalyst, a small, specialized flock of ducks. As these waterfowl move across the water's surface, their physical paddling gently agitates the soft sediment resting at the bottom of the pool, unlocking and re-releasing deeply trapped nutrients back into the active water column. Simultaneously, their nitrogen-rich manure dissolves directly into the aquatic environment, acting as a potent natural metabolic spark. This continuous nitrogen footprint serves as the foundational fuel for rapid, explosive algae development, initiating a highly productive food chain completely from scratch, while generating hundreds of nutrient-dense eggs for human harvest as a secondary byproduct. To prevent this constant nutrient influx from overwhelming the system and turning toxic, the architecture deploys a highly active biological plant layer, anchored by extraordinarily fast-growing species like duckweed. Functioning as an automated, non-mechanical biological filter, these plants clean the water by feeding aggressively on excess nitrates and phosphorus. Duckweed possesses an extraordinary metabolic structure, capable of doubling its total physical biomass in as little as 48 hours under ideal environmental conditions. This high-protein plant layer serves a dual purpose within the loop. It continuously sanitizes and balances the aquatic environment while providing an immediate, self-replenishing, natural food source for the surface waterfowl, looping the energy directly back into the primary engine. Beneath the surface of the water, the animal architecture is divided into rigid, non-competing ecological niches that utilize every square inch of the volume. Bluegill populate the upper layers, foraging actively on surface insects and maintaining permanent population stability through continuous, natural reproduction cycles that eliminate the need to restock. Fast-growing tilapia occupy the mid-water column, efficiently converting the natural algae and abundant plant matter directly into consumable high-grade protein. At the absolute base of the system, exceptionally hardy catfish traverse the sediment layer, consuming organic debris, fallen matter, and recycling waste. Completely invisible to the human eye, Beneficial bacteria anchor the entire perimeter, processing waste through the nitrogen cycle by turning toxic ammonia into clean plant food. Because every single creature occupies a completely different layer and utilizes an entirely separate food source, competition and waste are completely engineered out of the equation. The true power of this 2,400-year-old framework is not found in its raw caloric metrics, its low startup cost, or its minimal space requirements. Its real value is absolute systemic independence. Modern civilization has conditioned us to rely on incredibly fragile global supply chains, industrial food monopolies, complex shipping networks, and highly volatile market pricing. But by stepping away from the fragile paradigm of linear consumption and cooperating directly with natural biological cycles, we can establish a permanent, self-cleaning food engine in a small corner of a backyard. The ancient pools of the past prove that we do not need to dominate, alter, or artificially force the environment to survive. We simply need to build the loop correctly, step back, and let nature feed itself.